In this video, we are going to see about quartiles in statistics. What is quartile? In statistics, a quartile which divides the number of data points into 4 parts, or quarters, of more or less equal size. In other words, quartiles are the set of values which has 3 points dividing the data set into 4 identical parts. One thing we need to keep in mind is that data points can be random, and we have to put those number in line first, on the number line in ascending order, and then divide them into quartiles. It is basically an extended version of the median. Median divides the data into 2 equal parts, which quartiles divided into 4 parts. Once we divide the data, the 4 quartiles will be 1. First quartile or lower quartile, basically separate the lowest 25% of data from the highest 75%. 2. Second quartile or middle quartile, also same as median, it divides numbers into 2 equal parts. Number 3. Third quartile or the upper quartile, separate the highest 25% of data from the lowest 75%. Quartile formula. Lower quartile Q1 equals n plus 1 multiplied by 1 by 4. Middle quartile Q2 equals n plus 1 multiplied by 2 by 4. Upper quartile Q3 equals n plus 1 multiplied by 3 by 4, where n is equals to the number of data points. Examples of quartile. Question 1. Find the quartiles of the following data: 4, 6, 7, 8, 10, 23, 34. Step 1. Arrange the number in ascending order. 4, 6, 7, 8, 10, 23, 34. Here the numbers are arranged in the ascending order, and number of items, n equals 7. Step 2. Apply the quartile formula to find the quartiles. Lower quartile, Q1 equals n plus 1 multiplied by 1 by 4, th item. Q1 equals 7 plus 1 multiplied by 1 by 4 equals, second item equals 6. Median, Q2 equals n plus 1 multiplied by 1 by 2, th item. Q2 equals 7 plus 1 multiplied by 1 by 2 item equals, fourth item equals 8. Upper quartile, Q3 equals n plus 1 multiplied by 3 by 4, th item. Q3 equals 7 plus 1 multiplied by 3 by 4 item equals, sixth item equals 23. Question 2. Find the quartiles of the following age: 23, 13, 37, 16, 26, 35, 26, 35. Step 1. First, we need to arrange the numbers in increasing order. Therefore, 13, 16, 23, 26, 26, 35, 35, 37. Number of items, n equals 8. Step 2. Apply the quartile formula to find the quartiles. Lower quartile, Q1 equals n plus 1 multiplied by 1 by 4, th item. Q1 equals 8 plus 1 multiplied by 1 by 4 equals, 9 by 4 equals, 2.25 th term. From the quartile formula we can write Q1 equals second term plus 0.25 multiplied by third term minus second term. Q1 equals 16 plus 0.25 multiplied by 23 minus 16 equals 15.25. As 2.25 is between third term and second term, we can write Q1 as second term plus 0.25 from 2.25 multiplied by difference of third term minus second term. Similarly, median, Q2 equals n plus 1 multiplied by 1 by 2, th item. Q2 equals 8 plus 1 multiplied by 1 by 2 equals 9 halves equals 4.5. Q2 equals fourth term plus 0.5 multiplied by fifth term minus fourth term. Q2 equals 26 plus 0.5 multiplied by 26 minus 26 equals 26. And upper quartile, Q3 equals n plus 1 multiplied by 3 by 4, th item. Q3 equals 8 plus 1 multiplied by 3 by 4 equals 6.75 th term. Application of quartiles. Application 1. Quartiles are used to calculate the interquartile range, which is a measure of variability around the median. The interquartile range is simply calculated as the difference between the first and third quartile, Q3 minus Q1. In effect, it is the range of the middle half of the data that shows how spread out the data is. Application 2. Quartiles let us quickly divide a set of data into 4 groups, making it easy to see which of the 4 groups a particular data point is in. For example, a professor has graded an exam from 0 to 100 points. Say that professor wants to give bonus points to the top 25% of students, remedial instruction to the bottom 25% of students, and a chance for extra credit to the middle 50% of students. If the professor knows the quartiles are 55, 62, 75, 88, and 95, then it makes it easier to see where the dividing lines are. Got a 73? You're in the middle 50%. Got an 89? Congrats, you're in the top 25% of the class. The middle 50% of the data can be useful to know about, especially if the dataset has outliers. If the minimum or maximum values are far away from the central 50%, then there are probably some outliers in the dataset.
If you have any doubts regarding this topic, please comment down below. I will respond as per my best. Signing out.